everyone, welcome to Vidmahi Maths Academy. The next most important question is the domain of the function defined by f of x is equal to 1 by root of greatest integer of x whole square minus greatest integer of x minus 6. First thing, we should identify the rule of the function. So, f of x is 1 by root of expression. So, this is of the form 1 by root of expression. If it is of the form 1 by root of expression, expression should greater than 0. That means expression is what? Greatest integer of x whole square minus greatest integer of x minus 6 is greater than 0. Now, observe here the left hand side of the inequality. Greatest integer of x square minus greatest integer of x minus 6. This is of the form quadratic equation form. So, first factorize the terms so that split the middle terms. So, how to split the middle terms? 3, 2, 3 minus 3 and plus 2. So, that greatest integer of x square minus 3 into greatest integer of x plus 2 into greatest integer of x minus 6 greater than 0. That implies in these two, greatest integer of x is common, take out as a common. Next, what are the remaining terms? Greatest integer of x minus 3 plus in these two, 2 is common, greatest integer of x minus 3 which is greater than 0. Now, greatest integer of x minus 3 into greatest integer of x plus 2 which is greater than 0. Now, consider the number line. Consider the number line. On this number line, this is minus infinity, this is plus infinity. Greatest integer is equal to 3, greatest integer equal to minus 2. So, minus 2 and 3. Okay, there are three intervals: minus infinity to minus 2, minus 2 to 3, 3 to infinity. Now, in between minus infinity to minus 2, consider any one of the value. For example, if you consider minus 3. Okay, if you consider minus 3, substitute here. Greatest integer of minus 3 is what? Minus 3. Minus minus is negative. Next, greatest integer of minus 3, minus 3. Minus 3 plus 2, that is negative. Negative into negative is equal to positive, that is greater than 0. In between minus infinity to minus 2, if you give any value, greatest integer value is greater than 0. That means this function is greater than 0. Next, in between minus 2 to 3, give any one of the value. For example, if you give 0. Okay, now what is greatest integer of 0? 0. 0 minus 3 is negative. Greatest integer of 0 is 0. 0 plus 2 is positive. Negative into positive is negative. So, that is less than 0. In this interval, the function is less than 0. And now 3 to infinity, consider any one of the value. For example, 4. So substitute here 4. Greatest integer of 4 is 4. 4 minus 3 is positive. Greatest integer of 4 is 4. 4 plus 2 is positive. Positive into positive is positive, that is greater than 0. So in this interval, the function is greater than 0. Okay, suppose the given function is normal kind of function. For example, it is of the form x minus 3 x plus 2 is greater than 0. Then we can directly consider minus infinity to minus 2 union 3 to infinity. That is the domain of the function. But observe here, the given function is not a normal kind of function. It is a greatest integer function. For this kind of function, we have to use some another rule or another tricks to find out the domain. So in this number system, you already observe minus infinity to minus 2, that is greater than 0, and 3 to infinity, that is also greater than 0. That means less than minus 2, less than minus 2 case, greatest integer, and greater than 3 case, in these two case, minus less than minus 2 case and greater than 3 case, for all these case the inequality is greater than 0. Correct? So that means greatest integer value should be less than minus 2. Greatest integer value should be less than minus 2, or greatest integer value should be greater than 3. Greatest integer value less than minus 2 means what? If, for example, if you substitute greatest integer of minus 2. What is greatest integer of minus 2? Minus 2. Okay, what is greatest integer of minus 1 point, minus 2.1? What is greatest integer of minus 2.1? Minus 3. What is greatest integer of minus 2.5? That is also minus 3. What is greatest integer of minus 2.999? That is also minus 3. What is greatest integer of minus 3.1? That is minus 4. That means except this value, that is greatest integer of minus 2, in all these less than case, minus 2.1, minus 2.5, minus 3.1, so on, in all these case greatest integer value is less than minus 2. That means x should be less than minus 2. X should be less than minus 2. Now observe here, greatest integer value should greater than 3. Okay. For example, if you consider greatest integer of 3, greatest integer of 3. What is greatest integer of 3? 3. What is greatest integer of 3.1? 3. What is greatest integer of 3.9? 3. What is greatest integer of 3.99999? That is also 3. What is greatest integer of 4? Exactly 4. What is greatest integer of 4.1? 4. What is greatest integer of 4.8? There also 4. That means we need the value greatest integer value as 3, greater than 3. Correct? That means except all these values, that means this, except all these values at x is equal to 4, x is equal to 4.1, that means x is greater than 4 values. X is greater than or equal to 4 case, then only greatest integer of x is greater than 3. If you give x value as greater than or equal to 4, then only greatest integer value is greater than 3. So therefore, now we have to combine these two values. Therefore, domain is equal to minus infinity comma minus 2 union closed interval 4 to infinity. Here it is open interval because x is less than minus 2. Here it is closed interval because x is greater than or equal to 4, equal to 4. So therefore, minus infinity comma minus 2 open interval union closed interval 4 comma infinity. This is the domain of the function. So minus infinity comma minus 2 union 4 to infinity. Option C is the correct one. Correct answer. I hope that's all for today's demo on domain. If you found this explanation helpful and easy to understand, then this is just a glimpse of how we teach mathematics at Vidmahi Maths Academy. Subscribe to our channel for more maths lessons. Like, share, and comment your doubts. Thank you for watching. See you in the next video with another exciting mathematical concept. Thank you.